I will talk about cyclic process as well as a Carnot cycle. First, we will talk about the cyclic process. When a system, after completing a series of changes, returns to original state, it is said to have completed a cycle, and the process known as a cyclic process. The internal energy it depends on its state. In the cyclic process, the internal energy will be zero. It means delta U is equal to 0. According to first law of thermodynamics, delta U is equal to Q plus W. Therefore, Q is equal to minus W. It means that work is done by the system. There have two conditions. First is if change is in a cycle at constant temperature is known as isothermal cycle, and the second one is if the change is carried out reversibly is known as a reversible cycle. The reversible cycle process is theoretically and imaginary state. The most well-known cycle process is the Carnot cycle. It is Carnot cycle. We will talk about a Carnot cycle. The Carnot cycle is theoretical ideal thermodynamic cycle processed by a French physicist. When a system is taken through a series of different states and finally returned to its initial state, it convert maximum return to its initial state. It convert maximum heat into work. The system consists 1 mole of an ideal gas which is subjected to series of 4 successive operations, and we can say 4 successive stocks. The first stock is isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. First we will say first stock is isothermal expansion. In isothermal expansion, the gas is allowed to equally irregular and irregularly and at T2 temperature. So the volume of represented by V1 and it expand through V2 and it is located at A and B. T2 is a temperature. Now, uh, the work is the internal energy of isothermal expansion is 0. Therefore, Q is equal to minus W. We can first I see for a cyclic process. Now, let's Q2 the heat absorbed by the system and the temperature T2, and W1 will be the work done by the system of a surrounding. Now, the Q2 is equal to minus W1 is equal to RT2 ln V2 by V1. It's first equation. Now, the second stroke adiabatic expansion. In adiabatic expansion, the volume of gas V2 is expanded by V3 and initially work is done by the system. It is not a particle to stock the heat. Particle does not absorb heat. The temperature of a system, therefore, T2 to say T1 as Q is equal to 0. Therefore, according to first law, delta U is equal to minus W by convention. Convention delta U is equal to minus W. For the definition of Cv is equal to du by dt at constant V. Therefore, delta U is equal to Cv delta T is equal to Cv. Cv, the value of Cv is minus T2 minus T1 is equal to minus W. minus W is equal to CV T1 minus T2 is equal to minus CV T2 minus C1. We will change only two term T1 and T2. It means T2 minus T1. The minus sign is occurred. Therefore, minus W2 is equal to minus CV T2 minus T1. It means work done by the system. Now, the third one is isothermal compression. In isothermal compression, the volume of V3 is compress the volume V3 to V4 and the temperature is occur T1 temperature. The pressure is P4. It is known as the compression and the work compression process. The work is done by the system. It means delta U is equal to 0. That means minus Q1 is equal to W3 is equal to RT1 ln V4 by V3. Now, the fourth stock adiabatic compression. In adiabatic compression, reversibly compression and the original volume and the molecule is volume V4 to its original volume V1. Let's see. V4 to V1. There have no temperature occur on this state. Therefore, delta U is equal to Q plus W and the work is done on the system. It means Q is equal to 0. W is positive. Therefore, delta U is equal to W CV delta T is equal to CV T2 minus T1. Let's see the value delta T is equal to T2 minus T1 because of the temperature change. Delta T means change in a temperature is equal to T2 minus T1. So initial temperature minus final temperature. Okay. W it means W4 work. W4 is equal to CV T2 minus T1. Let's see the net heat absorbed by ideal gas. Net heat means Q. It absorbed by ideal gas. It means that Q is equal to Q2 plus minus Q1. The value of Q2 is equal to RT2 ln V2 by V1 minus the value of Q1 is equal to RT1 ln V3 by V4. The light of adiabatic expansion CV ln T2 by T1 is equal to R ln V3 by V1 as well as CV ln T2 by T1 is equal to R ln V4 by V1. Now combine the both equation. It means that V3 by V2 is equal to V4 by V1. The net heat will be absorbed according to equation 8. Now the equation 8 will be RT2 ln V2 by V1 minus RT1 ln V3 by V4. But the net heat will be absorbed. Net heat will be absorbed. So Q is equal to Q2 minus Q1. Therefore R T2 minus T1 ln V2 by V1. The net work done by the gas is W is equal to the net work. W it means the net work is equal to minus W1 plus minus W2 plus W3 plus W4. The summation of 4 stocks. 4 work stocks. The summation of 4 work stocks. It means that RT2 ln V2 minus V1 minus CV T2 minus T1 plus RT1 ln V4 by V3 plus CV T2 minus T1. It means that W is equal to RT2 ln V2 by V1 minus RT1 ln V3 by V4. Since V2 by V1 is equal to V3 by V4, V2 by V1 is equal to V3 by V4. Therefore, W is equal to R T2 minus T1 ln V2 by V1. It means that the equation 10 and 12 shows that Q is equal to W. It means the net work done by the system is equal to the net heat absorbed. Thus, the essential condition for a cyclic process that the net work done is equal to the net heat absorbed.